once filled by mighty lakes, has been scoured by floods of biblical proportions.
You can make estimates of how much water had to have been flowing to carve these things, and you get numbers like 100, 200 Amazon rivers all cutting loose at once. You need big, big amounts of water flowing across the surface.
The other big attraction on Mars is the largest volcano and highest mountain in the solar system. Olympus Mons towers at an astounding 17 miles, 3 times higher than Everest. Its base covers more ground than the United Kingdom, and the massive caldera at its summit could easily swallow Greater London, Paris, and New York.
So things tend to be big on Mars. I think in part that's because the planet has lower gravity. And so when you pile up lava, you can pile it 3 times higher because the gravity is 3 times less before it'll start to collapse under its own weight.
Mars is a far more active world than previously thought. We see landslides of dust and gullies freshly carved by outflows of mysterious fluid. And this peculiar region has been claimed as a flash-frozen sea, complete with fossil icebergs. Likewise, there are glaciers, geologically recent, but now buried beneath a protective blanket of dust, waiting for the next change in climate. Still, most of the defining surface features of Mars were carved way back in the good old days.
Certainly, something happened in the early history of Mars that led to great releases of water. And of course, people wonder, with that much water, could there have been ancient oceans? Could there have been environments that were very much like life environments on the early Earth?
Early Mars was a different world. A world with a thicker atmosphere, with weather and water, possibly a vast, shallow northern ocean. This was really the time to go to Mars, when you didn't need a spacesuit. Perhaps just an oxygen tank and some warm clothes.
When we reconstruct in our imaginations Mars of 3 billion years ago, we tend to make it like Earth, warm and cozy, but it wasn't. Mars, back in its wettest, warmest phase, was probably like Earth today in its coldest regions. So I'm imagining a place where the snow and ice is melting in the summer to form transient ponds and streams and ice-covered lakes. It's cold, it's wet, but it could be rich with life.
This is the Mars that we want our astronauts to get their hands on, to bring back and study. The wet Mars of old, where we might find the evidence of life. The fourth rock from the sun has always had a special card to play, the chance of meeting Martians. And in recent years, the odds of a close encounter have been steadily improving. If you want to find life on Mars, first, you need to find water. And not all of the planet's water story is ancient history. There's been plenty of frozen underground evidence detected from orbit, but scientists needed to touch and taste it to be sure. In 2008, they finally got their opportunity when NASA's Phoenix lander made a daring approach to the high Martian Arctic.
60 meters. Candidate sequence initiated.
There was not ever more excitement in my life than landing safely on Mars. I've been through the opposite. I've been through a landing that was not successful, and I did not want that to happen again.
The landing was not only perfect, but the engines exposed suspicious white patches directly underneath the spacecraft. Water ice was just a few scrapes away.
We did find water ice, and we found that the soil in connection to it has calcium carbonate, a compound that forms in the presence of liquid water. If it had been wet, then we wanted to look for nutrients and food sources that could support microbes.
The water ice is proof of a valuable resource for any life form still clinging beneath the surface, and for future travelers.
We now know that these plains that you see stretching behind me are underlain only 2 or 3 inches deep by a sheet of ice, all the way as far as you can see. Great hockey rink. If you had a hockey team on Mars, all you need is a broom.
The possibility of running into Martians received another boost from a very Mars-like part of our own planet, Chile's extraordinary Atacama Desert.
The Atacama is special because it is just so profoundly dry. Speaking roughly, it's 50 times drier than Death Valley. It is deader than Death Valley. It's the only place on Earth where a Viking could have landed and searched for life and dirt on Earth and not found it, and instead found a reactive mixture of chemicals. The only place. We can take a small step into Mars. We can test ourselves. If we can't find the life in the dry core of the Atacama Desert, we're not ready to go to Mars.
Perhaps we are ready. Because even here, in the driest corner of the driest desert on Earth, life has confounded scientists. Cyanobacteria have been found living inside the rock-hard salt of a long-gone lake.
This is a halite, it's a sodium chloride salt, which is colonized by cyanobacteria. It's dark green because they have this particular pigment protecting them from the excess of UV light.
Once in a blue moon, a fleeting early morning ground fog delivers some rare humidity to the air above the desert. This precious moisture is greedily sucked into the microscopic pores of the water-hungry rock salt.
This is a very rare event. So these bacteria are living in an environment where liquid water is available a few hours during 1 year. Very, very hard.
If we're looking for Martian bugs, we should search for life forms at least as tough and alien as this.
I'm looking at Mars from the point of view of a microbe. And as a microbe, I really need a very, very tiny amount of water. I could probably live my entire life happily in a tiny drop of water about the size of the point of a pen. Now, we've shown over the years that organisms that live in salt crusts on the Earth have enough sunlight coming in so that they can go through their day-to-day activities but still be protected from the radiation. And we know there's salt crusts on Mars.
Scientists are gathering clues about where on the Martian surface you should land to have the best chance of meeting the neighbors.
In terms of current habitability, I think the most interesting place on Mars is right where the Phoenix lander sat. That ice will be warmed when Mars is tilted toward the sun, which occurred as recently as 5 million years ago. That ice would have been warmed and wet, maybe even swampy.
Mars has a long-term wobble to its orbit, and every 5 million years or so, the poles end up tilting 45 degrees toward the sun.
A way of thinking about the Phoenix landing site is think about the polar regions on Earth. Imagine you're there in winter. It's very inhospitable, very cold, very alien. You think, how can anything survive here? Come back 6 months later, and it's like a different world. The sun is shining, it's wet, it's warm, things are alive and scurrying around. So we may be being misled, seeing this frozen, cold site, and in fact, we're just there at the wrong season.
We know that on Earth, some bacteria can survive being frozen for millions of years. They can also eat perchlorate, the highly reactive chemical Phoenix found in the Martian soil.
Presumably, if there was life at the Phoenix site, it had learned the same trick. And so there might be organisms that are literally eating the rocks and reacting with perchlorate below the surface, shielded from the ultraviolet light, just having a great old time 5 million years ago. The party is over because everybody froze, but another 5 million years, the party will start up again as the Martian summer comes to the North Polar regions and the ice turns to water.
The party might not be over everywhere. The gas methane has been found both by spacecraft in orbit and by telescopes from Earth. It's chemically impossible for methane to survive for long in the Martian atmosphere, so it must have been released recently.
Now, what makes methane? Cows make methane. It's probably not cows. Microbes of various sorts can release methane. There are a variety of geologic processes. Volcanoes can release methane. So the mere fact that there's methane doesn't say life. But either way, the methane says that Mars is an active planet. It's either biologically active or it's geologically active, or both.
The methane release appears to be seasonal and linked to areas of suspected subsurface ice. Ice found exposed in fresh craters has proven that water lurks not only near the poles, but also much closer to the equator. It's pretty clear that if the Viking landers had dug just 4 inches deeper, they would have reached this ice, and perhaps a totally different conclusion about life on the red planet.
So if Mars has any life at all, whether it is so small you can only see it with a microscope, or if they had a mammoth, it wouldn't matter to me. It's the whole question of, is there life at all on Mars?
Either way, there certainly will be life on Mars the moment the first human traveler arrives. The fact that there are no scheduled flights to Mars hasn't stopped people from preparing for the trip. And for a flight like this, planning is everything.
And there we go.
In 2009, 6 men walked into a series of connected rooms inside a warehouse in the Moscow suburbs and shut the door behind them for 3 months. They took all their food with them and drank recycled water. The only communication with the outside world was electronic, with a 20-minute delay. They were trying to simulate a flight to Mars.
You've got to think about what it's going to do to a crew to be cooped up in a small environment, but for that huge period of time, they're going to be the first people in the history of their species to travel that great distance, to be so far from home where they can't even have a normal telephone conversation with their family, with their friends. So we shouldn't underestimate what psychological problems might do for them.
There is no room to screw up on a trip like this, mental or otherwise. Once on Mars, you are likely to be stuck there for a year or more, waiting for a window of opportunity to ride home. And unlike a robot, the hopes and fears of the whole planet will be riding with you.
I think that humans are going to do a better job of exploring Mars ultimately than robots ever can. Robots move really slowly. Okay, what Spirit and Opportunity have done in 5 years on Mars, 2 astronauts could probably have done in a week.
As fast and as smart as we are, we still need mechanical help to scout the course for Mars. The next robot rolling on to red dirt will be aptly named Curiosity.
It's the size of a small car, and it has a nuclear power source, so you don't have to worry about dust accumulating on solar arrays or anything like that. And most importantly, it has the capability to look for trace quantities of organic molecules. So we've gone beyond now looking for evidence of habitability to actually looking for evidence of the building blocks of life.
Whether it's alive or dead, a trip to this red planet has a lot to teach us about our lonely blue one and the universe beyond.
Now, if you have two planets that are next to each other in the same solar system that both had independent origins of life, you would have to conclude that the chance of having life all over the universe, indeed, even in other places in our solar system, would be very high. I think, you could basically go to the bank and bet on it.
We're not going to Mars just to search for life. We're going to Mars to search for a second genesis of life. We'd like to find something that's different from us, that doesn't have the same genetic history and genetic code that we have. And from my point of view, the more alien, the better.
Now, the second possibility is that we find life on Mars, but my goodness, it has a genetic code exactly like us. It uses DNA. It's too coincidental. This is representing our cousins. Life either arose on Earth and went to Mars, or actually more likely, that life originated on Mars and it was transported on a meteorite or a comet to the Earth early on, and in fact, our home planet is Mars.
So in some ways, a voyage to Mars could be a voyage home. Our ancestors have made such bold trips before. When we walked out of Africa, when we sailed over the horizon. If it's technically possible, our ships will head out again.
We've always wanted to see what's over the next hill, and Mars is that next over the hill. Sure, you're going to have to be in a suit, you're going to have a habitat, but it's a solid planet, it's got a surface, you can see, you can work, you can explore.
I've thought for about 30 years now that we could go to Mars, and usually when people ask me how long it would take, I say 15 years, because we've been saying 15 years for the last about 4 decades.
Oh, a human mission to Mars can't happen soon enough for me. I'm a robot guy. Okay, that's what I do with my career, is build robots and send them to Mars. But I also think that we send things to Mars for reasons other than science. Our rovers, Spirit and Opportunity, were built by people who, like me, grew up in the 60s watching Mercury, Gemini, Apollo on TV as little kids and dreaming of sending spaceships to Mars someday. And now we do. And I think as people watch the first human explorers on the surface of Mars, they are going to be similarly inspired to do things that I can't even imagine at this point. It's going to be very costly. It's going to be dangerous. But I think it's something I'd certainly like to see happen. I'd love to see boot prints in our wheel tracks. I would love to see boot prints on Mars.
When the first human footprint is made on Mars, it will represent more than a giant stride into space. This one small impression will be proof that humanity is once again on the move. Travelers once more moving beyond our comfort zone to explore new lands and new opportunities. And have no doubt, there are many worlds out there ripe for exploration.